Okay. Assalamualaikum. I'm Muhammad Adam Fifin bin Sani Amril. I'm the student number 2 for this lab 2. So I'm going to be answering and explaining question 2, 4 and 6. Okay. I'm going to be starting with question 2. Okay. And as you can see, this is the line of code that has been given for question number 2. You can see here Arval is still unknown. Xval is 26, Yval is 30, Zval is 40, and this is the main code that will be executed. So let's start executing. Before that, here I put breakpoint at each of the line because I want it when I start debugging. I'm going to pause it at each line so I can look at the value of the register at each line. Okay, let's start debugging. Okay, here the registers appeared, and you can see EAX here is 00C6FB10, right? Because we haven't executed line 1 yet. We are going to execute line 1 after we step over. So what will happen when we execute line 1? Let's see. See, the value of register EAX changed into 0000001A in hexadecimal. Why did this happen? Because in line 1, we are moving the value of xval, which is 26D, into the register EAX. So, 26D in hexadecimal is 0000001A hexadecimal. Therefore, that's why register EAX value is that. Okay, so now let's execute line number 2. Okay, here we can see that register EAX has once again changed again into FFFE6 in hexadecimal. This is because in line 2 we are negating the value of the register in EAX. Previously it was 26D, right? Now when we negate it, it will become negative 26D. So negative 26D in hexadecimal is right here. FFFE6 in hexadecimal. That will explain why the value of the register EAX change. So step over again. We can see here the register EBX has changed. This is because we are moving the value of Yval, which is 30D, into the register EBX. And 30D in hexadecimal is 00000001E. Okay, next. In line 4. So what happened in line 4? The register EBX changed once again into FFFFFF6 hexadecimal. This is because we are subtracting the value of the EBX register with the value of ZY, which is 40. Previously, the value of EBX was 30D, right? And the value of ZY is 40. So 30 minus 40 is negative 10. Negative 10 in hexadecimal is FFFFFF6. Okay. That's all for line 4. So let's go into line 5. You can see here the register of EAX has changed into FFFFFFDC hexadecimal. This is because we are adding the value of EBX into EAX register. Okay, so previously the value of EAX was negative 26D and the value of register EBX was negative 10. When we add those two together, we will get negative 36D, and negative 36D in hexadecimal is FFFFFDC hexadecimal. Okay, next. Set over. Okay, so for line 6 here, the value of EAX has changed once again into FFFFFFDD because we are incrementing the value of register EAX by 1 here in line 6. So previously it was negative 36D, right? When we increment it by 1, which mean we add it by 1, it will become negative 35D, and negative 35D in hexadecimal is FFFFFFDD. Okay, so for the last line, line 7, we are moving the value of EAX into Arval. So now Arval here will contain negative 35D. So that's the value of Arval. Execute. Done. So that's all for question 2. We will proceed to question 4. Okay, we are continuing with question 4. So this is the line of code that has been given, and here I have added once again the breakpoint so that I can check the registers for each line. So let's start debugging. Okay, we can minimize this because this is what we want. So here we can see that EAX has not changed yet because we haven't execute line 1 yet. We will execute once we step over. Okay, so let's step over. Okay, here we can see that the value of EAX has changed into uh, 0028 in hexadecimal because in line 1 we are moving the value of var1 which is 40D into the register AX. So 40D in hexadecimal is 28 hexadecimal. That's why the value of EAX register is 28 hexadecimal. So let's move on to line number 2. What will happen? Okay, in line number 2, here we can see that the value of register EBX is 0005 hexadecimal because we are moving the value of 5 into the register BX. Okay, so now let's execute line number 3. So what will happen in line number 3? We can see here the value of EAX has changed into 00C8 hexadecimal. This is because in line 3 we are multiplying the value of AX, which is 40D, with the register value of BX, which is 5, and 40 times 5 is 200 decimal. So 200 decimal in hexadecimal is 000C8 hexadecimal. That's why the value of AX is 000C8 hexadecimal. Okay, let's step over. Okay, here we can see the value of EBX has changed once again into 000A hexadecimal. This is because in line 4 we are moving the value of var2 into the register BX. So the value of var2 is 10 decimal, and once we move it into the register BX will also. Okay, so here we can see that the registers EBX has changed once again into 000A hexadecimal. This is because we are moving the value of var2, which is 10 decimal, into the register BX. So when 10 decimal move into register BX, it will be 000A in hexadecimal. And then let's step over again. The value of EBX has changed once again into 0007 hexadecimal. This is because in line 5 we are subtracting 3 from the value of the BX register, which is previously 10D before. So 10 minus 3 is 7D, and 7D in hexadecimal is 0007 hexadecimal. Okay, so now we are going to step over. Okay, so here in line 6 we are dividing BX. So what does this mean? This means we are dividing the previously value of BX, which is 7 decimal, with the AX value, which is 200 decimal. So once we got that, 200 divided by 7 is, so here we will not get an even number because there is remainder and there is also quotient. So the quotient will be going to the EAX register, and the remainder will go to the DX register. So 200 divided by 7 is 28, which is the quotient. That's why you get 001C hexadecimal in register EAX, and you get 0004 hexadecimal in register DX because that is the remainder. And so that is what happened in line 6. And now we are going to step over. Okay, so now we are moving the value of register AX into var4, because here var4 you can see it is unknown. So now the value of var4 contains the value of ax, which is 001c. Okay, so that's all for question 4. Okay, so for question 6 is pretty simple. I've been tasked to write a full program, and this is my full program. And in the program, I've been tasked to clear the dx, and then move A03H into AX, move 10H into BL, divide BL and call down rex to show all the registers. So how to do that? We just start with the debugging, and here is the result. So I'm going to be explaining the result. Okay, so why did I move 0 into dx is because I want to clear the dx register, and then I will move A03H, which is 2051 decimal, into the register AS, and I will move 10H, which is 16 decimal, into register BL, and after that I will divide BL. So what will happen is 2051, which is the value of AX, will divide with 16 decimal, which is the value of BL. So 2051 divided by 16, we will get the remainder and the quotient. So the remainder will be in the DX register, and the quotient will be in the AX register. So 16, so 2051 divided by 16, we will get the quotient is 128 decimal, which will be put in the AX register, and 3 as the remainder, which we will put in the DX register. So 128 decimal in hexadecimal is here, 0380 hexadecimal in register AX. But you can see here EDX is 000. It should be 3, right? Why 3 is not there is because here you can see in the first line I have cleared DX 0. That's why DX is 0, even though it should be 3. So this is why the result is this. So that's all for my explanation. Thank you.